finished a world tour, as you know. Many of you would have attended a city or maybe two. And so what we're doing now is we've put together a collection of the best. So it's sort of like the Whirlwind Tour, we're calling it. It's the Best of World Tour 2014.
Right, so in the next, about 75 minutes, you're going to hear 5 or 6 different user stories. Again, this is like lightning talks, celebrating different users around the world, some of the things that they were presenting and weren't able to come and share with us directly. And so we've got a variety of staff, as Don and I were saying. There's a lot of moving parts here.
Yep.
I think it's like karaoke.
That's right,
about
PowerPoint karaoke.
So they're all, I don't think almost anybody's presenting their own slides here, so it should be fun.
Yep.
Sit back and enjoy and see a taste of the kind of things you're going to be hearing all the rest of the conference in more depth from all of you. So, who's our first?
Our first speaker is Aaron Koning from stage.
Talking about the power of one.
That's right.
All right, thanks guys. What is the power of one? Well, you're about to find out, so strap in here. We're going to talk about, first of all, this is a presentation provided by Renato Salva-Leone from Georgia Power down in Georgia. And we're going to do a bunch of this stuff. But background on the company, Georgia Power is an electrical utility provider. They provide power to about 2.25 million customers. And Renato works in the land department, which they do land engineering, they do land management. And they support, through GIS and other means, data management, they support transmission, distribution, and generation projects for Georgia Power. In their organization, they have about 200 users that use GIS in some manner. Renato himself is 11 years into GIS. Before that, 14 years in military. And he has a GIS, he's a certified professional. He's got certificates in surveying, in GIS. And he started with FME in 2006 in what he calls a love-hate relationship. He didn't quite get FME. It wasn't until 2009 when he discovered the power of one. So what is the power of one? He defines it as the one thing that you need to understand or the one business need that you have that you should try and meet. So with FME, you can do a lot. You could look at your whole organization and try and do something to put FME in everywhere there. Or you could just look for one business need and try and meet that need. And that's the power of one, finding that one need. So we're going to look at 4 use cases here from Renato and Georgia Power. The first, a fairly simple use case. What they have is they have a GIS viewer that shows survey points, survey control points, and they get that information off of from NOAA. Now NOAA updates that information every month, which means to keep that up to date, they have to do a manual process to bring that data in. So what Renato said was, well, let's use FME to automate this process. Let's grab that data off FTP from a zip file, let's read it in, read out the shape files, and then load it into STE. Very simple need that they had, and they met that with FME. They didn't try and invent a huge system. So that was the first sort of discovery. Hey, I can load to STE. Then they said, well, the power of one is kind of additive. When you discover one thing, then you add on another thing, and you get a better solution. And so they also said, let's create an ArcGIS server web map service as well to display the new layer. So they continue to build on their solution. The second case, fairly simple still, but they were moving from a non-spatial environment over to still a non-spatial environment, but moving more towards SDE. So they use FME to bring document tables, properties, maps, letter files over into an SDE environment, still non-spatial. Then they want to geocode that information. So what's the power of one here? Well, they discovered a transformer called the feature merger. And the feature merger simply takes 2 data sets and joins them based on a key. So they had existing GIS information with locations. They take that and they merge that with the documents, and now they have geocoded documents. So very simple, and they found that one transformer they needed to make it happen. With workflow management, they have, in this case, a process that involves 4 different people. There are vendors that submit information in geodatabase format, environmental specialists with that domain knowledge, which then clean the data and go through it. Those people actually then load that data into STE. Then you have a GIS analyst that does what all GIS analysts love to do, convert data. It's actually wrong here. They convert GIS data to CAD. Everybody loves to do that. And then they send it on to the mapping department, which then makes maps out of it. So they have this whole workflow, and they thought, well, how can we pick certain pieces out of there and automate them, just certain small pieces. And so what they did is they looked at the environmental specialists, them having to manually load that data into SDE, and they made that an FME process. So now that environmental specialist simply hits the run button. Same with the GIS analyst. They said, well, you're having to spend a bunch of time creating labels and styles for this information to have a nice CAD drawing. Let's have FME do that. So now you're more of a button pusher, which means you can fire the GIS analyst. No, you don't fire the GIS analyst. What you do is you allow the GIS analyst to maintain the workspace. So you maintain that workspace and you take them out of the critical path for getting that data to the mapper. That's the workspace that they created. They started by simply, the first part was loading to SDE, and then the next part is doing the CAD. And so they build it up with pieces into a bigger solution. And then since the GIS analyst has so much time left, they say, well, why don't you actually automate another process, which is extracting data from our SDE database for specific electrical lines. And they say, okay, I can do that. But I would like a nice interface to that. I'd like to select just my line. How can I have an option to just select my electrical line? So then, using the Power of One, they go and look for that specific thing that will allow that, and that's published parameters. Finding that published parameters, implementing that, and they achieve what they're looking for. Now going the other way, going from GIS to CAD, there's a need to do that, and one of the problems, they tried a lot of different things, and it was hard to really make that process smooth. They discovered that Esri and Autodesk are always improving and enhancing their products and formats. So FME is always at the same time there to come along and give a big kind of group hug to CAD and GIS and really allow them to play nicely together. So FME to the rescue. And the mappers, they said, okay, mappers, we want you to provide GIS data. And they said, okay, we'll do it at the end. We'll just dump it out there. We'll figure it out. And they said, no, the manager wants it done at the same time that every day you're actually doing the data. Let's have GIS synchronization. And then put it into SDE, and the mappers kind of went, well, what? So what they did is they wanted an easy button. They want to stay within AutoCAD. They want to be able to get that data out and have just an easy, smooth process to get that into GIS. So with Civil 3D, you can export to SDF, and that's what they did. They exported to SDF, and then they had basically this workspace which converts from SDF to SDE. Really, it's the power of one letter. It's just going from SDF to SDE. Very simple. That's all they had to achieve. But nothing brings it home more, the power of one, than this use case here, which is power of a single transformer. And it's not even really the use of the transformer, it's more the threat of the use of the transformer that was the success here. They didn't use it in production, but they came back, they were looking for some parcels in a certain area, some properties, and they were quoted $600,000 for a 3-year contract. It was a lot of money. They didn't have the budget for that. They were had a problem that there weren't very many data providers, so they only had one option. And they went to the provider and they said, okay, what do you have? And they gave them this text format data. They said, we have the parcels you want in this weird text format. But it's going to take a month for our sister company to convert the data and give it back to you. And they looked at the text format and they said, oh, I don't know anything about it. But they sent it into SAFE, and they asked FME, our support staff, what is this data? And it turns out it's well-known text. And that's where they discover the power of the geometry replacer. So the one transformer that can convert that data into boundaries and avoid that whole month-long delay. Which meant they could go back, say to the vendor, we don't need to wait the month, and we don't want to actually pay for this processing. We just want that text data, and we'll do the processing ourselves. So they were able to get a really lower, quite a bit of a lower quote out of them. And this had an added benefit. Another business unit was coming along and saying, we also want to get some parcels. They had a similar quote. The quote was from the sister company that said, we need to process the text data and convert it into boundaries and all that stuff, and it's going to be gazillion dollars, and George Power said, no, 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 we're not going to pay that. We're not going to pay that. And they did the negotiations, etc. And what came out of that? They didn't have to pay that bit. And not only that, but they no longer had to actually do the processing themselves, because the vendor said, okay, well, we know it's not actually a big deal, so we'll process that and give you the boundaries as well, and we won't charge you that much. So they went from really what was $600,000 down to $105,000 using just one transformer. So that's the power of one. So some people say to wield the power of one, you have to be born with that power, but you don't. You don't actually have to be. You can beg, borrow, and steal workspaces and transformers and things off of FME. You can get trained for free. If you haven't been trained for free, please do. Take up the training opportunities. Go on to our webinars, check out our demos on FMEpedia. And if you've done that kind of stuff and you can't find the answer, maybe you got a strange text file format or who knows what, some data you can't figure out, send it to support@safe.com. We'll be able to look at that and we'll be able to help you along. And a couple more things. Renato says, remove the context of the tool. So although you have a tool you work in every day, remove that and look at your business needs specifically. And how can you meet that and find out a way if FME can actually do that. But what it comes down to is achieving that business goal. Focus on that one need and see if you can meet that with FME. Looking ahead, they're going to do some more stuff with FME Server. They're going to add email notifications, synchronize their different enterprise systems. They're going to share out translations that are commonly used onto the web to allow users to access those and to self-serve and sort of take it to a next level. But it all starts with that one transformer, that one workflow that meets the need, and then it just grows from there. All right, thank you, and we're going to move on to Iris Katowski. If you have questions, we're always going to be out there at lunch to talk.
Thank you, Aaron. So I'm going to move on and I'm going to share with you a talk that I was fortunate enough to hear out at the City of Austin on our World Tour this year. And this is a talk about leveraging FME Workbench and Python to create stylized oil and gas CAMZ data sets. And this was a talk given by Marco Terrazas, who's a GIS analyst with Talisman Energy out in Austin. And just to give a bit of background, like many companies, Talisman has a fairly core GIS department that's doing all of their updates and managing their spatial data. But there's a much larger group at the company that likes to visualize their data on the map and work with this data, but they don't really want to dive deep into GIS. So the need that Marco set out to solve with FME was to get this data out of his file geo database that he uses all the time in ArcGIS into a KML file, which all these other groups like operations, engineers, and finance can look at and view in Google Earth. So this is what he set out to do with FME. So here's an architecture diagram of what he was attempting to do, and we see there's kind of two branches here. And at the beginning, he really wanted to offer a decision between two workflows. So in one case, at Talisman, they've got a lot of data, and the main thing that's frequently updated is their pipeline data. So he wanted a separate workflow for handling the pipelines, as this would be run much more frequently on a more regular basis as those updates happen more often. And another comprehensive workflow that updates all of the different data sources that they have there. And so the way he built that decision in there, he actually wrote a custom little internal web app that calls FME Server in the background. And in that web app, users can choose whether they want to run the full update or just the pipeline update. And sitting on the server are two workbenches. And these workbenches are combining a bit of Python at both the beginning and the end to do some pre and post processing. And in the middle of it, there's a workspace that goes from a file geodatabase to a stylized KML KMZ file. So to give you a little intro about startup and shutdown Python scripts, this is a really cool functionality in FME. I don't know how many of you have explored this before, but what these allow you to do is they allow you to perform things on your data before an FME reader even touches them. So you can manipulate your source data somehow before we even read it. And generally, we try to discourage this. We do offer a lot of transformers, and we try to get people to use the transformers, but there are certain cases when there's a little bit of extra that you can get out of the Python by calling, say, a third-party library or function. And in Marco's case, it was a bit of data maintenance that he's doing beforehand before reading with FME. And likewise, with the shutdown script, you can manipulate your output after it's, your file is completely written, closed by FME. You can say do something like move it up to, use a system call to move it somewhere else on your system, upload it somewhere, take advantage of the full power of Python. And that's really a great thing. We really want to give you all the tools you need to get your job done. So in Marco's case, his workspace starts out with this startup Python script, and what he's doing is he's calling the ArcPy Python library, which is Esri's Python library, and he's going to call the compress function, or the compact function, to compress his file geodatabase. And this is something that a lot of people might neglect, but when you're using a file geodatabase and you're updating frequently, a lot of inserts and deletes, what's happening is your file is becoming more and more fragmented, and it becomes slower and slower to read. So it's good to run a utility like this to clean it up, to compress it, so that it reads a lot better, you get a lot faster performance, and he's really seen, he gives this as a big tip, it's really important to do this on a regular basis. And by adding this into a workspace like this that you're running regularly, it just kind of packages it away so you ensure that it's done on a fairly regular basis and your compression is happening. So that's what Marco's doing with his startup script. His actual workbench here is fairly simple. He's starting with this is just the pipeline piece, but he's starting with his file geodatabase. He's got a feature class of his pipelines. He's reprojecting with one of our transformers I'll talk a bit about later. Then he's filtering out, he's got some logic to filter out for different statuses of the pipelines, which are stored in an attribute. And based on those values, he's going to style accordingly to create that output that'll allow the users to visually see the progress of their various projects. And all in the end, he's going out to KML, or actually KMZ. And the first thing here is the reprojector, and actually Marco is taking this a bit further. As many of you know, in FME, we try to automatically reproject for you. KML files are always in the WGS84 coordinate system, and FME is smart enough to know what your source data is if you have a set coordinate system and go right to WGS84 as best as possible. But sometimes users want that extra bit of control, and that's what the Esri reprojector does. So by using this transformer, Marco is using the same reprojection engine that he's going to get in all of his Esri tools. So he's ensuring consistency with, say, something he might do in ArcMap. So he's using this transformer, and also because he's going from an older datum model, he's going from a NAD27 datum-based model to WGS84. That involves a geographic transformation as well. So he's got that extra control over that. He can choose the exact geographic transformation that he wants to use there. So that's a great use of this transformer. As we see here is his source coordinate system where all their data sets are. And where the fun part where we're making everything pretty with our KML file is with the KML styler transformer. So if you haven't tried this out, highly recommend it. It's really fast to get some cool output going. So here he's coloring the pipelines based on that status attribute. You can also set up icons and do quite a bit there, very customizable with the styling. And lastly, here's the full total workbench that's handling all of those different feature classes, not just the pipeline, but the well pads and the leases and all of those other things. Lastly, when this is all finished and his KML file is written, Marco's taking advantage of Python again in a shutdown script. And the script that he's doing here, pretty short and simple. He's actually using Python to just call a batch file. And what this batch file does is it's manipulating FME's log because the translation's done, the log's finished. So he's just written this script to kind of clip our log. So I know there's a lot of work been put into all these messages that we print out there, but some of you just don't want to read them. You just want to see the end, see did this succeed. So that's what he does. He clips it down to just the very end where he sees the features written, and he actually is going to have this batch script pop Notepad up, so we'll see right away if his translation went as expected. Yep, this is what it looks at. So he'll see, oh, everything I read got written out. I'm good to go, and he knows he gets that instant feedback there. So kind of a cool use of that. And unfortunately today I don't have the ability to run Marco's demo live like he did in Austin, but he did send me an example of it run on a very critical new acquisition at Talisman. And there we go. So this is one of their major new pipelines here. Very efficient shape here. And we see actually some of our savers inspired the names of some well pads out there. So this is the end product, and this is something that would be shared with various groups along in the company where they could easily view what's happening, the progress of the pipelines. And also they can inspect with the KML styler. You can also add in these text balloons. They can also view hyperlinks. So in his case, internally, they would connect to their SharePoint by clicking on a hyperlink for each parcel, and they could get information about leases and all of that, all of those documents. So from this one file, they can kind of go and find all the information they need. And also a kind of a cool feature that I think is often overlooked is that watermark where it says he added the FME logo in there, and that is actually a writer option just right out of the box. So if you've never found that, I'd take a look. You can really make a nice looking report like that, add in a legal disclaimer or something like that. Things you learn from this. So in the end, I'd really just like to thank Marco for sharing this talk with us. And if you're interested in learning a bit more about Python and FME, we've got a training course coming up this Friday. So if you're in town, I'd encourage you to check that out. And I think I'm all done, and I'm going to pass it off to.
Okay, thank you. So on our FME World Tour in the UK, we showcased a session from Barnsley Council. Barnsley Council, the guy there, Riley Marsden, the main guy working with FME. Those of you who aren't familiar with the geography of the UK, Barnsley Council is in the north of England, just in the middle here. More well-known cities of Manchester and Sheffield in that local area. So it's a very small government unitary authority. Barnsley has a very focused Pitney Bowes stack. They use MapInfo Professional, they use Stratus Online, and they have data in a number of different locations. Quite a lot of their traditional data is in the Oracle environment, but they're at the moment moving over to SQL Server. They also have a significant amount of data in non-spatial or tabular environments. Actian is one of those, and it includes a lot of things that traditionally we wouldn't have thought we could use or manage with FME. Benefit information, taxation information, and finance data. Riley also states that they have more access and Excel spreadsheets across the network than they know what to do with, so a real challenge, which means that FME is starting to become a real go-to solution for them. The interesting part of this project was that we engaged with them very early on because they needed to do a data migration project. They needed to move from Oracle to their new standard, their new corporate standard SQL Server. They also had a significant amount of budget cuts that they were going to have to suffer and had to have a 30 million budget reduction over recent years and a lot more than that over the following 3 to 4 years. The sad fact was that during our engagement with them at the very early part, they went from a team of 4 to a team of 1. So the capability of automation was really pertinent here. Riley had to do a lot of the tasks that his colleagues had done, which many of them which weren't automated, they needed to be automated. He had a very focused idea of what FME was going to do for them. It's going to control their input data, carry out checks and validations, and to be able to, most importantly, produce consistent results. It needed to do the same thing every day and every week. And we had a little snapshot. We charted their use of FME in this case study literally over 6 months, from purchase and procurement through to using FME for a whole host of capabilities. One of those was, quite a few of them actually, were focused on populating their WebGIS. In the UK, the National Health Service has an NHS Choices API that allows access to all of the traditional health service capabilities in the United Kingdom. It's accessible via a URL that you can pass in with different components. So here you can see that we're passing in the service type, which is accident and emergency hospitals, around a postcode, pass in the API key, and then within a kilometre distance of 40 kilometres. So we can dive over and pass that URL into a web browser and pull back all of the hospitals that are within 40 kilometres of the centre of Cambridge. The interesting thing that will get all of you XML people hot under the collar is that is able to be delivered in different representations, and the XML content can be pulled out, and of course, FME can read that. We built a very quick process that allowed us to publish that data out to, in this case, some KML, but in actual fact, it went out to a MapInfo tab file to allow their Stratus system just literally to pick that content up on a weekly basis. Here we've got the hospitals with accident and emergency capabilities around the local area. In the case of writing to KML, we have a little image. We've got a URL that allows us to go and find out more detail from the NHS Choices site about Barnsley Hospital. So a neat little solution for them to be able to continually populate their web mapping system so that citizens can dial in to the website and find out what health services are nearby to them. There was a whole host of other capabilities that we went through. They wanted to engineer out a lot of the hard-coded map basic scripts that they had in the organization. One of them, for example, had 5 sets of scripts that took planning application data and loaded it into Oracle. One FME workspace resolved that challenge for them very quickly. It was a conflation operation and trimming down content to load into their planning system. They did some neat 3D PDF visualization to look at areas in the local authority that had low voting patterns. They wanted to know where individuals were not registering to vote. They needed to process ordnance survey data. That was a real easy task for them with some of the products that they could process with FME. They also needed to publish their local land and property gazetteer, their address information, to the national gazetteer. In order to do this, FME doesn't support natively this format called DTF, but it's a text structure, so using the text writer in a custom format. That format didn't need to elude Barnsley's capabilities. They neatly used the directory and file path reader, which I'll definitely heartily suggest you have a look at. Directory and file path names reader allowed them to scrape their network server to find all of the duplicate files that they had on their network to make sure that certain individuals weren't using the wrong data. They did a lot of address restructuring in spreadsheets to handle troubled family data in the local authority area. Another demo I'll do quickly for you is looks at their use of publishing roadwork information. In the UK, there's an organisation called Elgin that publishes to a site. It's a scraping site, essentially, called roadworks.org. This is an example of the site, a live feed directly, all of the roadworks in central London. These are all highway closures or highway works that are affecting the highway in one way or another. So an electrical company is doing some network operations on a street light. I don't know how that works, but there's Transport for London are digging up the road and putting in a new bus bay. And all of this is live information. Now, the fascinating thing was that Barnsley wanted to publish this information on their website, but they are a publisher to Elgin. But Riley had no way of getting hold of the data that they were publishing out to an external body, so they used FME to get it back from that published service. There's an irony in there, but it was a bit of a challenge, really, for them to cope with that. But Riley wrote a workspace, and away we go. There's a nod here to Dave Campanas, actually. I don't know whether he's in the room, but he helps us out here. This API it's a SOAP service, essentially. There is a SOAP sender transformer, a custom transformer available in the FME store, which neither us nor Dave could get his head around, so he came up with a little XML templating routine and an HTTP uploader that helped us here. Essentially, to pass in using a creator, a little bit of dummy geometry, we could pull out of that the Barnsley center bounding box, take the geometry out of that using the geometry extractor, and then pop that into an XML templater. And really, this is just an elaborate mail merge to populate it with values into the SOAP request and send that off. And the beauty of this is that now you can pass in any geometry and pull back all of the roadworks from this live service and display them anywhere you want in any application. This meant that In this case, we can see the roadwork information that we've just been looking at by supplier in the inspector. They load it into the database, but they've also gone one step further and built this into a custom format. So now any MapInfo user can open up a little bit of geometry, and it ultimately queries the SOAP service and pulls back the roadwork information for that location straight away. So it's a neat little solution for them, and they can view all of the individual geometries that are going to affect the road network and have that as a daily process that automatically runs. So they were pretty pleased with that simple capability to hit that SOAP service. Riley quoted, and I wrote this down when he said it to me, in just over 6 months, I've authored close to 50 workbenches. I'm addicted, to be honest. There was one stage where I got an email from him late at night when he said, I've actually been dreaming about an owl and a tuna fish sandwich. The owl was eating the tuna fish sandwich, and the owl was writing a better workspace than me. So clearly he'd been using FME a little too much at that point, but he had a little bit of workspace blindness, perhaps. But so the next steps for them, I do wish this publication really existed, actually, but sadly it doesn't. Spreadsheet enthusiasts, for all of you tabular data professionals out there, FME is all about for cleaning data, and one of the things that they need to do is a lot of data cleanse, but they need to move back to that original project. They bought FME to do this data migration. Data migration wheels moved very slowly. They diverted themselves and carried out and did all of this cool stuff. And now they're ironically coming back to do the thing that they bought FME for in the first place. And to look at some more of these non-spatial or tabular processes that are required. So in this case, with very slim resources, FME is really helping them to transform their data, but actually connect applications is really significant for them. To allow these applications to talk to each other hands-free through this automated capability is really important. So I guess I'll close and say that if you see owls and tuna fish sandwiches, then you probably need to stop and have a little rest. But thank you very much.
It's great to be here. For me, this is a great opportunity. I work for Safe Software over in Europe, but just fantastic to see so many FME friends, staff, partners, customers. A really great opportunity for me. This story comes to us from the FME World Tour in Paris. So, and this is a story about using FME to drive a smart data system to support the smart city of Lyon in France. This presentation does not have what some people are calling the obligatory, very complicated workbench slide. I think this came up at the World Tour in Oslo. A woman put up a slide with a very complex workspace, and she said, here's my obligatory complex FME workbench slide. This presentation doesn't have one. I want to start actually by thanking Gregory Blanc-Bernard of Grand Lyon, who presented this at the FME World Tour in Paris, but also Olivier and his team from Vermees. Vermees is a platinum safe software partner. If you have any questions about this, what I'm going to talk about, Olivier is probably more equipped. Where are we? There he is. Could you stand up for us, Olivier and Frederic? These two guys are more equipped to answer any questions about this than I probably am. They did most of the implementation work of FME in this situation. So starting, just put up a definition of smart cities on the slide. There's a lot of definitions floating around, but I think the general idea is probably fairly clear to everyone that we're using information technology, communication technology to help create a smart city. I can't help but mention here this particular quote I got from an article on the 10 smartest cities on the planet. The number one smartest city on the planet, according to this article, was Vienna, who also used, guess which application like crazy, Vienna? FME, thank you, yes. So, but we'll focus on Lyon here. So the smart data is a platform. It's a project initiated, in fact, by the IT group at Grand Lyon. Grand Lyon is like an agglomeration or what we might call a regional district in Canada, a group of municipalities creating a regional district. And the Smart Data Platform is a platform for disseminating data to help build a smart city. This platform is live now. I'll open up the live site in just a second here. There's roughly 422 data sets available now. Many are coming from partners. So we have partners collecting data that Lyon has forged a relationship with to get that data and help share it out to the public as a whole. Some of the partners would be the City of Lyon, some of the other cities in this regional district. JC Dassault is the company that operates the city bike network in Lyon. I think Lyon was the first city in the world to have this sort of bike, where you can take a bike for just a little bit of money and ride it somewhere and drop it off somewhere else. I love these things. So that data is coming into this smart data platform from the region of Rhône-Alpes. The data services that are provided by this platform include data discovery, of course, so you can see what data is available, visualization, and then we have some download services, so OGC-KML and JSON is available. Many of these data sets are available in real time, and that's really what piqued our interest in this. I think most of you know that we're very excited about the real-time capabilities of FME Server. Obviously not a ton of customers using this kind of technology yet. So this one piqued our interest. We've heard about Palmerex, the weather network in Canada would be another one. So some of these real-time data sets are coming into their smart data platform through the use of FME Server. Tab over to the website here. So here's Don's daughter playing hockey. How do I get the... Is that your daughter, Dawn? Yeah. How do I do it? Like I said, I'm not the best person.
It should have been, hearing should have been on. Ah, there we go. Sorry about that, Ken.
That's good.
She loves XML as well. Okay, so now, got it?
Yeah, that's good.
Excellent. Sorry, there we go.
No, that's good. So, yeah, I think I said there was 422 data sets. Looks like there's 423 now. So these are being added in all the time. And we can see some of these are what we would think of as traditional static reference data sets, the orthophotography for the regional district. But you can see there we have the VELOV is actually the name of the bike network. I like that I don't know if you can read that, VELO, comma, V, so it's VELOV. Like I said, I love these little bike network things. And, there's many other data sets available on here. We've got drinking fountains. There's real-time traffic information that I'm going to come to in a second. The cadastral planning, so that's more of a reference data set that's static. So everything available through this platform. And you can see, I'll just tab over to one of the live ones that I have loaded. This, harsh to look at, this is a JSON feed of the bike station capacity. So how many bikes are available in each station. This is a real-time data set. Will F5 refresh a browser on a Mac here? Give it a try. So this is a real-time data set. So if I oh, there it is. Yeah, I got it. See, I don't even know how to use this mouse. There we go. Did that do it? Yeah. So this data set is refreshing through a real-time feed that's coming by an API that Le Dassault provides to the Grand Lyon Smart Data Platform. Back to the slides. Now we can't see it on here. There, I got a monitor down. Just to take a look at the architecture, so they're dealing with a three-tier architecture here. So we can talk about the back office. This is where FME's been used for a long time to compile some of the reference or static data sets like cadastral mapping, the road network, that kind of thing. There's been a long history of using FME in the back there. The middle office is where they're compiling data sets for pushing out to this smart data platform. So from the middle office, they're now using FME Server. Veremy's team implemented this system where FME Server is fetching some of these live data sets in a variety of different protocols from some of the platforms. So some of the platforms that I already mentioned were JC, Dassault. There's a live feed of data that's coming from traffic incidents, traffic accidents, similar to what David mentioned in Barnsley Council there. So that's kind of roughly the architecture. Just to put FME in a bit of context here, as I mentioned, Grand Lyon had been using FME for a long time already, FME Desktop. This was already used for internal compilation of some of these static data sets that I was talking about. So when they were looking to a solution to start bringing in some of these real-time data sets into the Smart Data platform, FME Server was an obvious choice. They were already familiar with FME Workbench, and it was kind of a similar, we could say that it's a similar solution to what they were doing with Workbench. Right away, I think some of the notification functionality provided by FME Server was providing some of these needs right out of the box. So one of the early ones that I think Olivier and I talked about a bit was a directory watcher service in a notification service. So FME Server can keep an eye on a directory, see if a new file has come, and then run a workspace when something appears there. And that's in fact how the real-time traffic data is coming into the Smart Data platform, is using the directory watcher service, which is watching an FTP directory. A couple of other things that made FME Server kind of an obvious solution for their real-time data provision would be the fact that it's scalable, and in their view, it was an economically viable solution to what they wanted to do. So some of the real-time data sources, they're coming from a variety of protocols, as I mentioned. Some are coming from sensors. We have accident reports that are coming in. Data managers are providing data. Some are coming from web services that FME Server can easily read from. Some are just being dropped as files on external servers. So the traffic data, as I mentioned, comes as this is an XML file that's dropped onto an FTP directory that ends up onto a directory that FME is watching, and then a workspace executes. The bike sharing data that I talked about, that comes from an API. Parking spaces are available as a JSON service. I think most of you know that FME is a very flexible tool for reading different data formats, but also reading from different types of data services. Some of the processing requirements that Olivier and his team were faced with at Verames, they required that the data was used right away when it appears. So when some real-time data shows up, it has to be processed immediately. That was one of the requirements. Also, a process shouldn't take more than 10 seconds. So once the data is there, 10 seconds, that was the limit. So this pushes us a little bit on the performance, but the way their team kind of fine-tuned things, it met the requirement pretty quickly. They needed to not interrupt the service for maintenance when they're connecting to it, to manage interruptions. So if there's an interruption in the flow of data from a partner, they want to send an email or send notifications through other means that there is an interruption. This wouldn't be an interruption caused by FME Server, but an interruption from one of the data partners. And they need to maintain a continuous availability of the data, continuous consistency in the database. And in fact, this requirement pushed us to do a little bit of work on our database side. Our PostGIS writer now has the ability to write a big chunk of data in a single transaction so that the database represents exactly what the state is in real time. So just to give this real-time traffic data example, a little bit more detail. So with the Smart Data platform, the idea is that users can create services, applications, can do all kinds of things that the city doesn't even know or necessarily care about. The idea is to open up the data to people to take advantage of it. So here, this was a little web application built on top of the real-time traffic data. You can imagine that the red is where traffic is not moving very smoothly, and the blue is where traffic is moving better. So how does this one come together? I won't go through all of this in too much detail. This is actually already a kind of a gross simplification of the process. But you can imagine that there are these magnetic loops under the road that measure traffic data. They communicate to a system operated by Grand Lyon via either radio modems or 3G, I should say. That data finds its way into an Oracle database. Within that Oracle database, they're running some processing to aggregate the traffic information by road segment. I'm trying to figure out where to look here, because here has not got my slides anymore. So every 60 seconds, roughly, from this Oracle database, they're pushing out an XML file that has the traffic flow information for those different road segments. When that happens, FME server sees the XML file. We're reading the XML. I think we've heard quite a bit about XML already this morning. Don can't help himself get excited. And then FME server pushes that out into a PostGIS database in this middle office that I mentioned, and then it gets pushed out into the real-time smart data platform. So that's kind of a detailed example of one of the real-time data flows that are coming from a partner and getting pushed out to the users, to anyone really that wants to build services or applications on top of that. And this is really a trend that we see a lot with FME use, is making data available, either open data, smart data, whatever you want to call it. The trend here is that FME is a great tool for pushing data out to people who can then take more advantage of it and build more on that. So some of the other known uses of this smart data platform that was created, I don't need to go through all of them, but Renault Trucks is actually a delivery system, an urban freight delivery system, so they take advantage of the traffic data. GeoVelo is a bike routing app that takes advantage of the data that comes from the Velev system. Another one I'll mention, Le Monde, is a newspaper in France that did an article on elections in Lyon, so they used some of the data that was available on the smart data platform. Veolia, a very large utilities infrastructure company, was using some of their data for their urban modeling platform to take a look at the big picture of urban modeling in the Lyon region. So lots of stuff happening there. And I think the point is that making this smart data available out there just creates a lot of opportunities, a lot of places for economic development in the region of Lyon. So once again, thanks to Gregory Grambernant, who's not here today, but also thanks to Olivier and his team very much for providing this example.
We'll see how good my Mac skills are. Yeah, it's great to see everybody here, friendly faces from near and far. And I really love, as Don mentioned before, I really love these customer talks, because this is really where the rubber meets the road, and how people are taking FME and applying it to real-world problems, and really cool, innovative stuff here. Fred Judson, I had the fortune of seeing his talk, maybe the misfortune of touring with Don and Craig. No, we had a good time. We were the East Coast team, and so that was actually our first stop, and it was one of the best talks for sure. There's so much that he's packed into it, and he's a GSP and has been using FME for a while, coming from the DOT background, CAD to GIS. And now he's kind of made the leap from 2D to 3D, and you'll see in this project that he's working on. I know I've only got 10 minutes, so I'm going to kind of fly through it. I won't go through history here. But essentially what his job is, he's the managing coordinator for the UAS Center for Ohio and Indiana. And what is UAS? Well, we would know these in terms of drones or UAVs. Maybe they're worried about the public reaction if they're talking about UAVs and drones. So they came up with a new name, unmanned aerial systems. So maybe systems are more friendly than drones. But anyway, there's going to be an explosion of use of this, and many different applications. And so they have a catalyst here for developing commercialization of this technology in those two states. So the background is that NASA is introduced this Airspace Operations Challenge, and so they're in the first phase, just wrapping up the first phase now, and the second phase is going to happen. So there's lots of prizes in terms of innovation and how to implement and support these industries and integrate it. Really, the whole point of this is how do you integrate this whole new form of aviation with the existing aviation industry. Clearly, you got to keep the unmanned and the manned stuff separate, and safety is of paramount performance. Here's a look at the industry. Currently at about 14 billion. That's set to double in the next couple, actually, no, sorry, currently about 7 billion. That's going to double in the next couple of years. And probably you're going to have the industry 10 times that size 5 or 10 years from now. There's a whole range of applications from managing all sorts of resource management, forests and agriculture, to law enforcement, and just overall infrastructure management. Instead of having to go and hire a helicopter to fly down your corridor, hydropower corridor, you can just have a UAV do that monitoring for you. So here's a few non-traditional applications. Taco copter, burrito bomber, lobster copter. So if you've come up with those ideas, sorry, they're already taken. Dominoes. Apparently, Amazon, maybe it was more of a publicity stunt, but Amazon was talking about delivery via UAV. And so then on The Onion, Fred mentioned in his talk that they posted an article that Walmart was going to have anti-UAV missiles on its stores. Some competition there, perhaps. But yeah, I'm not so sure. He was also talking about UAVs to deliver beer, but you know, if it's dropping beer from altitude, that could cause some controversy. So I think that was one application that was shut down for now. Okay. But ultimately, I won't read through this list of agencies, but there's a lot of agencies involved. But another way of looking at UAVs is just another sensor platform. The obvious thing is the air photos that you can get from it, but there's a whole wealth of telemetry that's coming from a UAV. If you're going to make use of those air photos, you have to know the exact position of them, the orientation, the time, the altitude, and so there's all of those things that can be now calibrated to maximize the use of those images. The overlapping images can now be used to generate point clouds, and then there's all sorts of other info that you might want to be collecting from a mobile platform like that related to weather, climate, environment. So one of the things that really has made this possible is this explosion of technologies, and also the miniaturization and the way the cost has come down. And so now you've got this flood of information, and as Don and Dale said this morning, we're drowning in this flood of data, and so the need there is for tools like FME to help integrate it. So the main, keep an eye on the clock here, the main use of FME really is in the whole certification application process, or in order to apply for what the COA, which is the Certificate of Authorization. And this industry is just overloaded with acronyms and terminology, so it's easy to get lost in it. Right off the top, in terms of airspace planning, they're using FME to read the FAA formats such as AIXM, and Don and I we love FAA because they're all about XML. So we talk about AXM, FIXM, WIXM, so that's the other ones are the FIXM is the flight management exchange standard, and WIXM is for weather. So obviously the average person, or let's say contractor who wants to do mission planning, they're not used to working with these XML formats. I can't imagine why, but they like to see something that they can visualize more easily, like KML. So what they're able to do is use FME to extract this data, build these 3D views of the data, and then they can plan. They can see exactly, not just in 2D, but in 3D, where those airspaces are, and they can do mission planning beneath those. So the red zones are where basically you're not allowed to go, and the green zone is the mission planning. And that's essentially what that certificate of authorization looks like, and that's what FME is helping to plan. And so basically there's a whole range of data that has to be integrated. You can see here that those polygons are actually at elevation, maybe 2,000 feet. So the UAVs can fly underneath that ceiling below a certain buffer. And there's a whole range of data that has to be integrated. I'm kind of running out of time. So basically, the workflow is they digitize the planned area of operations in ArcGIS. That gets loaded into SDE, and then there's a whole range of automatically generated results that go into the COA application that FME is responsible for. So this is really the core workspace. It's amazing how much he's packed in here. It's very much results driven. So on the right are all the outputs that they need in order to support, essentially automate that application process. And on the left are the data inputs. So the VOR, that's essentially a the acronym, very high frequency orientation range, sort of a range vector. The flight area where they're going to fly, the sectional charts which show the approaches to neighboring airports, and then the point boundaries of the flight survey area, and then a bunch of Excel data as well for that. And the inputs are those FAA flight charts, the Esri data in terms of just where it was digitized, and then the sectional charts and airport data. So obviously we don't have time to go through this, but you can see that FME really is playing a central role here in terms of bringing these very disparate data sources together and making that application process, automating that as much as possible. You know, this was a 40-minute talk. I'm trying to get through it in 10 minutes, talking fast, but I think got about, what, 2 more minutes? That. I'll just try to wrap up with a couple of highlights here. One of the main highlights as I flip through these slides is that, again, a lot of the people using these systems are not traditional GIS users. So a key factor here wasn't just integrating all of these diverse data sets together to support the application process. It was also to generate results that were very easy for them to interact with. So KML in 3D, Excel spreadsheets were very important, and also 3D PDFs. FME was used to do nearest neighbor calculations, so the nearest airport to every point. So that's another one of the requirements for the application. And here they even did some viewshed analysis. So not all the platforms are motorized. In this case, there's a balloon, so a stationary platform, and they wanted to basically see if that balloon is at 500 feet, what are all the locations that can be viewed from that point. So you can see the shaded area, and that was all done with FME. And of course, XML is central to this, both reading and writing XML. In this case, they have lost points that have to be, so if the vehicle goes off, there's a loss of communication between the base station and the vehicle. It has preset locations where it can land. And so just to wrap up, FME is used to both aggregate and disseminate the data. The aggregation of the data, things like mosaicing and then tiling and clipping, so things both raster and LiDAR. And also data distribution. They chose JPEG 2000 because they didn't have any licensing requirements. So yeah, here's, we don't have any more time, so basically just to highlight some of the other types of data that they're working with, and you can just see this is an ideal, it's a very big challenge, but it's an ideal problem for FME because it's 2D and 3D, it's raster and vector, it's database and XML. It's basically, all of the above. And moving forward, they're looking at using FME and FME Server for more data management. So you can see each of those points, they have an image, an air photo image that was taken that they can overlap with the neighboring image to compute an elevation. That exact point, that pinnacle of that rooftop, they can look at what is the accuracy of that height computation and interpolate between those multiple images. So being able to manage all that data. So that's all the time I have, but yeah, real thanks to Fred for his great work, and I'm really looking forward to seeing what else
Well, although we've already seen some impressive uses of FME and, really sophisticated uses. And so this is a complete step backwards from somebody who presented in St. Louis at our world tour, what it's like for a new person to start with FME. Who here has been using FME for less than about a year? Can we just get some hands? Yeah, so I think you're going to probably relate to this presentation. And for some of us that have, the rest of us are all FME hackers. So maybe we can sort of empathize with this, and then when we've got colleagues in your organization coming on board, or for us at Safe Software, when we're trying to bring on new users, we can see what it's like for somebody to get started with FME and kickstart into a new project. Karen Volker, she's with the St. Louis County. That's the county that sort of surrounds the St. Louis, city of St. Louis. I learned something there. I found out that the weather down there is a lot more variable than I thought it would be. I thought they would have a nice climate there, but it's pretty rough. But it's nice as well to know that Alberta is also exporting something as well as just muddy oil. They've got these Alberta clippers come down and give them a cold snap every once in a while just to wake them up. Karen has worked with the St. Louis County for about 18 months, probably about 12 months with the county when she first started doing this particular project. So the project was to convert their St. Louis County GIS data into the Esri local government information model. They decided that they would keep their county model, which they had been working on for a long period of time, as their production database, and then move that into the local government information model that Esri supplies, because that's a very good fit for getting your data online through some of the ArcGIS Online tools that Esri has, and makes that a lot easier. If you try and use your own sort of customized data model, apparently that's quite a bit harder to do, and you have to do quite a bit more programming. So they thought they would do this data replication task, move the production database into the local government information model, and then be able to serve up with the AGL apps to their customers and make a more open kind of data set. But there were a couple of problems with that when she was asked to do this. She wasn't familiar with the local government information model at all. She'd never heard of FME, actually, when her boss said, use FME to get this thing across, and she had no data migration experience. And so that was a big learning curve for her to get going with this project. So starting with the local government information model, she started going through their online resources. Actually, just before she started this project, one of my colleagues, Steve McCabe, had been working with Esri, and we've put up some templates for helping people move data into the various Esri model, and one of them was the local government model. So she was able to use that template as a kind of a starting point. But then she had the kind of realization that actually data migration is a little harder than you might think. What you've got to do is you've got your source data model, you've got your destination model, and you have to line those up somehow. And that's a lot of a bigger task than most people realize. Actually, it's a way bigger task than most people realize in these data migration projects. They always underestimate how much work there is in lining up data models between two different disparate systems. So that was a big realization for her. Here's a kind of a partial list of the feature class comparison between their county GIS and what the local government information model wants. And you can see there are big gaps there between the different feature data sets and the feature classes that they had in their data model and what the LGIM data model is expecting. This is another part of her mapping process. She said, well, I'm a geographer. I should build a map about this problem. So she built a spreadsheet that helped her map between the local, their county model and the LGIM. The gray areas there are pieces of the data that the local government model is expecting and that they didn't have. And the yellow lines there, just for the addressing, are the attributes that they had in their model that they wanted to get across into the local government model. They actually used a tool from Vertex 3 Systems. Steve is here who builds that tool for updating their local, the local government data model with the new attribution that they wanted to use. So this will suck in data model from the XML workspace document into a spreadsheet. You can then do the mapping, readjustment of the data model, and then it'll create a new database. So that's one of the tools she used in rejigging the local government information model to kind of more closely match with their needs. Okay, so then on to FME. She's kind of figured out how to map that data across from where it's going to come from to where it's got to go. And now she's got to figure out what safe software can do to help her do that with FME. So she plowed into our product. She took a bunch of our online training courses, sifted through FMEpedia, searched through our webinar pages. So we've got all these very disparate resources available to people. She printed out the valuable Transformer reference guide that there's copies out there that you can grab, actually, that a lot of our users love to have. So she found that super useful. Downloaded sample workspaces, including the template that we had for the local government information model, and then found out that all that is too much information. You go down a rabbit hole, all that looks cool, start playing around with that tool, and then she had to keep on bringing herself back and saying, you got to focus on the prize. What do I actually want to do with this thing, which is to move this data from A to B, and really try and focus on that. So pick out from all these examples the little bits that she needed to actually build the workflow that she needed to create to do that one task. And it was kind of a difficult process for a new person getting into FME. So she had a couple of templates she's working with, and then she decided to throw all those out and start from scratch. She really felt that working the problem from scratch with examples was the best way to use FME. So she kind of did this trial and error methodology. She felt that really built familiarity with FME. She never once called support. I got a couple of quotes from her, which I think just gets us into her mindset here about how she approached this problem. Suffer in silence. I will dig for an answer before I ever admit defeat. I don't want to call tech support if I don't have to. And I also feel like working the problem helps you gain a better understanding of the software. Well, that's good for support, for our team. But we hope that we're not such a scary bunch that you don't normally call us. So we would normally encourage Lauren to call us in future. Hopefully, now that she's met us through that world tour, that she'll feel a bit more comfortable doing that. Use the trial and error methodology. Well, I tried this and it didn't work, but maybe if I try it in this way, it will work. And when it does work and the light bulb goes on, it gives me a great feeling of triumph. And then I start thinking about it, how much better it could be, and I start the entire process over again. This lady's a bit of a pit bull. I'm glad she didn't call support, actually, because I think by the time she came up there, we don't know what kind of problem she's going to be throwing us. Anyway, this is a bit about what she thought about actually FME. I think geographers and cartographers, that's her training and background. She's a geographer. Like myself, tend to be very visually oriented. FME provides that interface that you can graphically see the interworking of the design and how it is being built. Coming from somewhere who could only minimally read code, this is a much better working environment. So that's kind of over her learning period, how she kind of got familiar with FME and really stuck to it. So she then, having explored the product, she came up with the kind of the transformation tools that she needed. And in the end, she realized that although the learning curve is steep and that we have 400 odd transformation tools, in most cases, people only use 15, maybe 25 transformers in their regular daily use. And so once you've figured out what those core transformers are, things get a lot simpler. Just a couple of the examples that she used here: the attribute renamer for rejigging domain, the attribute renaming, and the schema mapper, which is actually a fairly complex transformer, but a really useful one, and the attribute value mapper for rejigging a lot of the domain values and enumerated lists that she had within her data models. So she was using the attribute value mapper if the domains were small, the schema mapper if they were more complicated. This was her workspace, so the scale of her problem, she had about 43 feature classes that she had to move across. The facility site points was a kind of a 10-to-1 mapping from their problem to the county GIS. And so, it wasn't a trivial problem, but most of the workspace is actually, in the end, fairly repetitive once she got going there. So her moral for the story: I'm always learning that which I cannot do in order that I may learn how to do it. That's kind of not like the unknown thing that Donald Rumsfeld threw it out at us, I think. But anyway, I think it was really interesting for us to see a young woman who was a geographer, had never heard of our product, figuring out how to learn the product. I hope next time she starts on a project, she can feel more comfortable about calling our support team, and I'd encourage, of course, everybody else to do that.